Okay, we're in section 14.3 where we get to verify trigonomic identities. A trigonomic identity is an equation that is true for all values of theta in its domain, which means like if it's the variable is theta, it's it's considered, anywhere between 0 and 360 degrees. Um, it's broken up into different categories, trig functions, where it means that we can rewrite different trig functions in different emphasis. So, like for example, we have our reciprocal identities, which means that cosecant ends up equaling 1 over sine theta, secant is 1 over cosine theta, cotangent equals 1 over tangent theta, and respectively sine theta equals 1 over secant, cosine theta equals 1 over, I'm sorry, this is 1 over cosecant, cosine theta is 1 over secant, and tangent's over 1 over cotangent. The next one is tangent and cotangent identities. Tangent theta, another way of writing it is sine of theta over cosine of theta, and then cotangent n equals cosine theta divided by sine theta. And the rest of them in your notes talks about Pythagorean identities. Pythagorean identities are derived from both the unit circle and from the Pythagorean theorem. So the part where, like, I see the first one where it's sine squared theta plus cosine squared theta equals 1, that comes from, the 1 comes from the unit circle, because the circle in the unit circle is radius r, which is 1, and then the Pythagorean theorem from a squared plus b squared was going to equal c squared. And then the other identities that correspond with that are derived from that unit circle Pythagorean theorem combination. The next category is cofunction identities, where if you were to have sine of pi over 2 minus theta, it'll end up equaling cosine of theta, and cosine of pi over 2 minus theta ends up equaling sine of theta, and then tangent of pi over 2 minus theta equals cotangent of theta. And then we have, the last thing we have is negative angle identities. So if I have the sine of negative theta, I can take that negative value and put it on the outside, which will make it negative sine theta. Negative, or cosine of negative theta ends up equaling cosine of theta, and then tangent of negative theta will end up equaling negative tangent of theta. So all of these identities are going to help us solve different trigonomic expressions. So first thing that we're looking at is, for example A, they tell us that the tangent of theta ends up equaling 5 over 12. And then the parameters that they give us is that theta is in between pi and 3 pi over 2. And those are in radians. So if you're still having trouble with radians, it's not bad to convert it to degrees to help you out. So this here can be rewritten as pi is the same thing as radian 180 degrees, and it's less than or equal to theta, and it's less than or equal to 3 pi over 2 in degrees is 270. So when you're doing a problem like this, theta is going to be in the third quadrant. So if I were to make a graph here, this is the first quadrant, this is the second quadrant, third, and fourth. So the first quadrant, the parameters here are in between 0 and 90 degrees. Here it's going to be 90 degrees and 180 degrees. This one here is 180 degrees and 270, and this one's 270 and 360. Okay? So with that being said, our theta is going to be in between 180 and 270. So that means I'm going to have a reference angle somewhere in the third quadrant, and my reference angle is always going to be towards my x-axis. And here, if I make a triangle, a right triangle, it looks something like this, and they're telling us that the tangent of theta ends up equaling 5 over 12. Well, tangent is opposite over adjacent, so I'm going to go opposite, which is 5, and then adjacent, which is 12. But if we look at this a graphical sense, my x value is going to the left 12 units, which actually makes that a negative 12. And then my 5 is actually going downward in my y coordinate, so that's actually a negative 5. Which then still holds true with my positive 5 over 12, because negative 5 divided by a negative 12, those negative values will cancel to make positives. So it still holds true, but we have to keep that in mind when we're doing the other 6 trig functions to help us find those values for those other trig functions. So they tell us what tangent is, so what we need to find is we need to find what sine of theta, cosine of theta, we need to find cosecant, secant, and finally cotangent. Well, in order to do that, we need to find what the hypotenuse is for that triangle, and we can do that by using the Pythagorean theorem. And we know that our two legs are 12 and 5, but we can use a squared plus b squared equals c squared. So negative 12 squared is 144, plus negative 5 squared, which is 25. That ended up equaling 169. And the square root of 169 gives us a value of 13. So now I can use the definitions of whatever sine, cosine, cosecant, secant, and cotangent to help us solve those other trig functions. So sine is opposite over hypotenuse, so this is going to be negative 5 over 13. Cosine is going to be negative 12 over 13. Cosecant is the reciprocal of sine, so this becomes negative 13 over 5. Secant is the reciprocal of cosine, so this is negative 13 over 12. And the last one is the reciprocal of tangent, and that's going to be 12 over 5. Okay? These examples here, we're going to get into simplifying trigonometric expressions. So what I mean by finding a simplified trigonometric expression, I want to just use one trig function, whether it's squared or cubed or whatever it is, but I just want one value to determine what the end result's going to be. And here's what I'm talking about. So if I look at example A, I have the tangent of pi over 2 minus theta multiplied by the sine of theta. Well, if we go back to our first page, we have some trig identities that are going to help us out. And if you end up looking at that, the tangent of pi over 2 minus theta ends up equaling cotangent of theta. And that can be multiplied by the sine of theta. So we still got two values, so let's see if I can do some cancellations. Cotangent, in our notes, they told us that can be also written as cosine of theta divided by sine of theta, and it's multiplied by the sine of theta. And I have a sine of theta in the numerator and the denominator, so these can be canceled. So the simplified expression for this is just the cosine of theta. Okay. Next, I have tangent of negative theta multiplied by cosine. So go back to my notes. I can rewrite this as negative tan of theta multiplied by cosine of theta. Next, I can rewrite negative tangent by the negative sine of theta over cosine of theta multiplied by cosine of theta. I have cosine in both the numerator and in the denominator, so those cancel. So I'm left with the negative sine of theta. C, I'm going to determine that, well, let's say, I'm going to rewrite secant theta times cotangent squared theta plus 1 over sine theta can be rewritten as secant theta. Okay? Looks like I have two secants, so maybe I can combine something with that. So let's take a look-see. I can rewrite cotangent squared theta. I can rewrite that so I got secant theta, and I can say in parentheses this could be multiplied by secant squared of theta minus 1 plus secant theta. So now I can distribute this and distribute that, so this becomes cosecant cubed minus secant theta plus secant theta. So plus and a minus, these actually will cancel out, so my simplified expression is going to be the cosecant cubed of theta. And then finally for D, I have sine of theta plus cosine of theta times cotangent of theta. So first off, let's go sine theta plus cosine theta multiplied by cotangent, but that can be rewritten as cosine of theta divided by sine of theta. So if I were to multiply this out, this is going to give me sine of theta plus cosine squared over the sine of theta. The way I can combine them is by finding my least common denominator. My least common denominator in this case is going to be sine of theta. So I can write this as sine of theta in both of my denominators. If I were to, since I multiplied the denominator by sine of theta, I must do that to the top, so that leaves me with sine squared of theta. I didn't do anything with this one, so I can just leave it as cosine theta. Now when I combine them, I have sine of theta on the bottom, and then I got sine squared theta plus cosine squared theta. Well, back from our trig identities, this is going to give my numerator as a value of 1 divided by the sine of theta. And the sine of theta ends up being cosecant theta. Okay? And this is the first half of verifying trigonometric identities. Hope this helps. Till next time.